Hello, my dear chemistry students. I know this has been a very heavy week of chemistry. There's a lot going on, and we're going to do some more crazy stuff here. And you're going to get it. I promise you, you're going to get it. You're going to hear it today and go, what in the world is she talking about? Unless you've ever heard this before, which seems unlikely unless you're just like a chemistry geek and you've been reading about chemistry when you were a kid. But even if you were, I don't think that you would have covered this. So we were talking about the different, those lights are annoying. Sorry, maybe if I scoot up, would it be so bothersome? Get myself organized here. Move things around. Okay, so we're going to talk about the quantum model of the atom. If you're in your book, it starts on page 114. So we talked about the Bohr model. That was where we ended last week. I'll try to go through this slowly and not talk so fast so that it's not confusing. It's going to be probably confusing anyway, and you might want to listen to this video and then listen to it again possibly, so that you hear it once and then hear it again with some understanding. I would make sure that you've read your book before you come to class. That would probably be helpful. I'll try to note that in your notes from Moodle or send it an email because you won't know until you're listening to this video that would have been a good idea. So the quantum model, let me get my notes here, which is today's model of the atom, is pretty much the same as Bohr's model. It just gets a little more complex. And the main difference is how those electrons orbit around the nucleus. So in the Bohr model, they were just kind of circling around the nucleus. And they could only be sort of on the edge of that circle. When we get to the quantum model, we just have different shaped orbitals, and those orbitals get more complex. And so that's what we're going to spend today, this video talking about. I'll probably put it into separate videos still so that it's easier to upload. So if you think about like a dog on a leash out in the yard, you've got a stake in the ground, and that dog can go anywhere in that radius of the circle. So it can go like stretch it out, it can go along the edge, but it can go anywhere in between that edge up until the end of the leash, that greatest distance that the leash will let the dog go. But let's say it's winter and the leash got wet and then it froze. And so it's like in this, I know that probably wouldn't happen like that, but just you can picture it. And let's say it's frozen in this like just stiff length. So now the dog theoretically can only go like around the edge of the circle from that point. That would be like the Bohr model. And the quantum model would say that electron could move, or that electron or dog could move anywhere inside that circle. Not all the orbitals are going to be shaped like circles, but that's kind of the visual imagery that you can use if that's helpful. Let me see. I'm just looking at my notes because I want to make sure I don't skip anything important. Nope. That's all I covered so far. Okay. Everything else about the model, like the electrons that are closest to the nucleus have the lowest energy, and the ones that are farthest have the highest energy, and electrons still want to be in that lower energy state. All those things are all the same. And the fact that they can jump between orbitals, but they won't be in between orbitals, all those things from the Bohr model hold true for the quantum model. So we're just going to expand upon these orbital shapes, okay, and begin to sort of create a picture of what these electrons are doing. So the very first orbital is called the s orbital. S, probably for spherical, because it's like a circle. There are 3 different energy levels that s orbital can exist at. And they call and follow in the book so you can see the pictures here because that will help. So on page 115, you'll see the 1s orbital, the 2s orbital, and the 3s orbital. They distinguish them by size, but it's not really so much size as energy. And we do know, though, that when there's greater energy, it is farther from the nucleus. So it is a size thing, but it's important to know it's an energy thing, too. The energy is increasing as we go from 1s to 2s to 3s. Let's just that, okay? So we've got a nucleus with these circles of increasing size or energy levels. I want to make sure you understand that energy level because those numbers, that 1, 2, and 3, that corresponds to an energy level. Okay, so try to lock that in your brain. That is really important. There's lots of, well, I shouldn't say lots. Did I say there's lots? I feel like there's only S, P, D, and F. Sorry, I'm looking at my notes here. Okay, never mind. Let's just pretend I didn't segue there. I was just thinking. Okay, so we have the s orbital, spherical. That helps you to remember it. And then we have the p orbital. I don't know what the p stands for. They kind of look like dumbbells. That doesn't help you with the p. I think you'll be able to remember that. It's not that hard. But the next shape. So the p orbitals, if you look at that picture in 115, they kind of look like dumbbells. So these two little roundish balloon kind of things sticking out. In a given energy level, so remember the energies are like 1, 2, 3, there can be 3 p orbitals. So there's 2 that are kind of connected like this horizontally, and then there's 2 that are vertical. Let's see. 2 are oriented horizontally, 2 are oriented vertically, and the third is oriented 90 degrees from both of the others. So if you look on, it's like you have 2 that are like on a crisscross like this at 90 to each other, like on the same plane, like going perpendicular, and then one that's perpendicular to both of those. Kind of like if you think of the coordinate graph, you have your x-axis and y-axis, and then I don't know if you can picture like the z-axis like coming out towards you. I think that's what it's called. It's on all those planes. Don't worry if you don't fully picture that well. We all have differing abilities to picture that in our brains. I can picture it now because I've seen it. There's a picture in the book that will help you picture it. If you can't picture it, it is okay. It will not hinder your understanding necessarily of what we are going to do. It is important, though, to remember that there can be 3 orbitals, though, for each p orbital. It's a weird way that they say that. It's the p orbital, but there's like 3 of those pairs of shapes within there. This is one of those things where it'd be helpful if you could see the big picture, because then this might make more sense to you, but it's hard to give the big picture without explaining all the steps up to it. And that's why I say listening to all this, and you're going to be listening to this in class with some teacher there, and maybe that teacher will have some knowledge of this, and they might be able to explain it a little bit, which will be great. If not, if you all listen to it and you're all in agreement, just play it again when it gets to the end so you can take the bigger picture and have that picture as you listen to all this again. So we have our spherical orbitals, our s orbitals. Then we go to our p orbitals, and it's just important to know that there are 3 per energy level. Let's just stop with that. Then we go to the most complex orbital. It's the d orbitals. There are f's too. We're not going to deal with f. We're just going to deal with d, up to d. And the d orbitals, as they say in the book, their shape is so complex it's really hard to explain. But the important thing to know is that there are 5 orbitals on the d level, or the d shape. Let's say d shape, don't say level. The d shape, there's 5 orbitals per energy level. So just kind of let that sink in. Just kind of accept it. Don't worry about why or do I fully understand it. Just kind of accept it. So let me look at my notes. Where are we at here? So those are all our shapes, right? Our shapes and how many orbitals there are per energy level. Within each of those energy levels, different shaped orbitals require different amounts of energy. So like, for instance, it's real easy to rotate in a circular pattern. So the s orbitals don't require as much energy. And as you try to make that p shape, it requires more energy. And as you try to make that real complex d shape, it takes even more energy. So even within the same energy level, like if we're at the 2 energy level, a d orbital is going to take more energy than an s orbital. Okay? Because they're kind of greater distance from the nucleus. And it's related to the complexity of the shape. So just kind of take that, just hold on to that. Here's a very important thing. Each of those orbitals can only hold 2 electrons. So when I am in the first energy level with S, that first energy level, there can only be 2 electrons. And when I go to the next one, that 2s, it's the second energy level for S, there can only be 2 electrons there. And then I go to the third energy level for S, there can only be 2 electrons there. And the fourth energy level for S, only 2 electrons there, okay? The p orbitals don't even have There's no p orbitals in the first energy level. They just don't exist there. They're too complex. They jump up to the second energy level, and that's where they start. In the second energy level, if we're on p orbitals, remember there's 3 of them for each one. So there can be 2, 4, 6 electrons for each of those in that energy level. Sorry, even my brain starts going, what am I saying? If I even start to stop and think about something else, I totally lose what I'm talking about. So when I'm on the second energy level with my p orbitals, I can have 6 electrons there. When I jump to the third energy level, talking about the p shapes, there can be 6 electrons there. And then the fourth level, energy level, there can be 6 electrons. So basically what I'm talking about p, every time if I'm filling them all up, then there'll be 6 electrons for each energy level. Then when I go to D, hopefully you're extrapolating and maybe beginning to think what D might be able to hold. D actually starts in let me double check. Where does D start? D starts in the third, right? Yes. D requires so much energy that it has no shapes in that first energy level, no, not shapes, but no orbitals in the first, no orbitals in the second. It starts in the third energy level. We're going to learn some things that will help this be a little bit easier to remember. So even though this sounds like a lot of information and there is some memorization involved, it won't be just flat out. It'll make sense. The periodic table is going to help you. So D shaped orbitals start in the third energy level because they just require so much more energy. And they have 5 orbitals per energy level. So each of those orbitals can hold 2 electrons. So 5 times 2 is 10. So there's 2, 4, 6, 8, 10 in one energy level. And then when I jump to the 4D, it can hold 10. And then 5, the 5th energy level, D orbitals, can hold 10. Let's rest with that. We're going to do some examples here together on a whiteboard. But we have that. Now, I feel like there was something I was going to say earlier. Did I skip it? Maybe not. Let me just look at my notes here. I feel like there was something I was going to tell you, but okay, we're good. So within the same atomic energy level, so energy levels are like that first, that second, third, fourth. Within the same atomic energy level, different shaped orbitals require different amounts of energy, right? We've kind of talked about that. The p orbitals take more energy than the s. The d orbitals take more energy than s and p in general. And then, hold on. Okay, so that's that. Sorry, I'm jumping around in my notes a little bit here, but that's okay. Okay, so energy level is related to shape. I guess that was just my note that I wanted to make there. And I already talked about 2 electrons, and then it's full. And so once that orbital is full, then those other electrons have to go somewhere else. And so they have to find the orbital that they fit best in based on their energy level. Only one orbital exists on the first energy level, and that was S. Remember, on that first energy level, there's only S because the p orbitals start in the second energy level and the d orbitals start in the third. So in the second energy level, there's just S and p. And then the third energy level, there's only P and D, no S. Okay, again, don't worry about memorizing that too much. It's going to come out in the wash really well, I promise. Okay. So they give kind of a summary in the book, and it's on page 117 towards the top. They say, they start with, this is the modern day view of the atom, and they give a summary, and then they say, this is what you kind of need to understand. And basically that summary says that the different energy levels have different shapes, and depending on the energy level, electrons have several different shapes of orbitals in which they can travel, and each energy level has its own requirements for the electrons. So that the shape has an energy requirement, and the energy level has an energy requirement. And the electron's going to go to the orbital and the energy level whose energy requirements it best meets. You don't have to worry about what that is, but that's what it's doing. It's finding which energy requirement of both of those, the shape and the energy level, that it best meets, and that's where it goes. And sometimes that can get messy. So for instance, 3D orbitals, so third energy level and with the D shape, they require more energy than 4s. So 4 sounds like a higher energy level, right? But it's an s orbital, which is a little simpler than d. So even though it's third energy level, it does take more energy than the fourth one with s shape. But again, you're not going to have to memorize that. There's a way for that to be figured out, so you don't have to be trying to make those complex decisions as you try to, you're like, as I try to what? It's going to be the next step as we try to build these atom kind of shapes and energy levels. So it's important just to understand that even though I'm in the fourth energy level, which sounds higher energy, that can actually have less energy if it's a more complex shape. So the energy level requirements are based on two different things, shape and energy level. So let's just pause there. I'm going to stop the video. I'm going to start a new one, and we're going to do some examples from the book. I'll say one. No, I will stop there. I will stop there because that's the end of the section. Okay, let me stop the video and start a new one, and we'll keep moving on.